Thank you so much for joining this lesson. Today we're discussing mathematics paper 2. That is the Mokasa joint examination 2025, paper 2, section 1. So welcome to the platform. Remember to subscribe. Remember to share so that you may invite a friend. It has actually been a while, but we are back. So feel free to continue supporting our programs and also to invite a friend. Number 1 is on errors and approximations. The dimensions of a rectangle are 40 centimeters and 45 centimeters. If there is an error of 5% in the measurement of its dimensions, find the percentage error in calculation of its area. So if there is 5% in the measurements, then it means we can get the range. If it's 40, for example, we can check where 40 lies. So we're going to have 40 can either be due to the error of 5%. So it can either be 95% of what you're having, or it can be a maximum of 105%. Therefore, we can take 95% multiplied by 40. This gives 38. So the lower limit is 38 centimeters. Then the upper limit is going to be 40 by 105%, which is 42 centimeters. Then the other dimension, which is a 48, we can also take the same error of 95%, this multiplied by 45, and we shall get 42.75. That is the lower limit. The upper limit of 45, we multiply it by 105%. This gives us 47.25. Now, at this point, we can now talk about the maximum area, the minimum area, then we go to what we are calling the errors now. So area minimum shall be given by the lower limits, 38 multiplied by 42.5, 0.75, 42.75. So what do we get here? 38 multiplied by 42.75. This is going to be, this one is going to be 1624.5 square centimeters. Then we talk about area maximum. Now the maximum area shall be, we use the upper limits, 42 for the first dimension and 47.25 for this second dimension. So 42 multiplied by 47.25. This gives us exactly 1984.5 square centimeters. Then we have the actual area, which will be given by the dimensions just as they were recorded, 40 by 45. Yeah, 40 by 45. This gives us 1800. 1800. 1800. 1800. So with this now, we can proceed to, I'm sorry for that. You know, we are already having maximum, minimum, and actual. So we can talk about absolute error in these computations. Absolute error in the computation. This requires maximum minus minimum divided by 2. So 1984.5 minus 1624.5. Then we take the average. So let's take now the average of 19, 4.5 minus 16 to 4.5. So I'm getting 360 over 2. 360 over 2. This gives us 180. Then now we can talk about percentage error. Percentage error is usually calculated by absolute error out of actual area times 100. And this is going to give us exactly, this is 18,000 over 1800. So I'm getting 10. Yeah, 10%. That is going to be 10%. As we continue learning, let me bring to your attention our programs here, whereby we are having some mentorship programs for the candidates of this year, 2025. So every Saturday from 7 p.m. to 9, we'll be dealing with grade 9 in mathematics, and Form 4s will be taking the Sunday. This interaction shall be in Google Meet. So this program is not just going to be very simple, it's something which is quite involving. Actually, it's an interactive class, just like any other, only that this one now is online. So please take an initiative of visiting our line here and make more inquiries about the same, so that we may see people improve together. So you are most welcome. Please join our programs. As we progress now to number 2, a question that says, we solve the following pair of simultaneous equations: x plus y equals to 2, x plus y equals to 1. And further, we are told that x squared minus 2xy plus y squared is equivalent to 4. So we're going to solve it. And I believe you guys are live with us. You are following, you're subscribing, and you're sharing. So please ensure that you invite a friend, at least a friend, not even 2 people, just a friend to the live broadcast. Remember to comment. Let's know where you're watching us from as we continue learning together. Number 2. Now, from equation 1, this one, when the pair is simultaneous, we talk about equation 1 and 2. So equation 1 can be expressed as x equals to 1 minus y. Then now we rewrite equation 2. Equation 2 shall be rewritten as, instead of x squared, now we're having 1 minus y, and everything should be squared, minus 2xy. So 2y times x. X is 1 minus y. 1 minus y. So instead of x at this position, we are having it as 1 minus y. Then plus y squared. This is equivalent to 4. So when we open the brackets here, we shall end up with 1 minus y squared minus 2y plus 2y squared plus y squared equals to 4. At this point now, we can group some terms together. Negative y squared, positive y squared. You see, now we are remaining with 2y squared minus 2y. Then we are having positive 1 and 4 on the other side. So if 4 is brought to the left hand side, it shall automatically become negative. So 1 minus 4, we get a negative 3. This is equal to 4. So we can take product of a times c. A times c. Yeah, a times c. That gives us a negative 6. Then sum of the value at b, which is a negative 2. Now, which 2 factors multiplied to give us negative? Multiplied to give us negative 6, added to give us negative 2. Added to give us negative 2. I'm trying to think about this particular terms, or we get back to the grouping of terms in this case. Yeah, there is an issue here. Just look at this, ladies and gentlemen. In this expansion, you know that is squaring. So when you square that part, it should have been, let me just take you back a little bit so that you may see what is happening. I'm actually going to expand there using the quadratic identities. When you are squaring such a binomial, we're supposed to start with the first part squared minus 2y plus y squared. Then now there is minus 2y plus 2y squared plus y squared equals to 4. So now we group terms. Y squared, y squared and 2y squared. So this part and this part, that becomes 3y squared. Then negative 2, negative 2. We can continue grouping terms. Remember, y squared is still being found here. So that is 4y squared. Then now negative 4y. Because of negative 2y, negative 2y, that becomes negative 4. Then we will be having 1 minus 4, which is negative 3, equals to 0. So now we can talk about a product equivalent to negative 12 and a sum negative 4. Yeah, sum negative 4. Sum negative 4, product negative 12. Therefore, at this point now, we'll be picking the terms or the factors. Multiplied negative 12, added negative 4. So these are negative 6, negative 6, positive 2. Yeah, negative 6, positive 2. Okay. So now we can re-express this one and say 4y squared. Instead of negative 4, we can talk of negative 6y. Then we add 2y minus 3 equals to 0. So 2y is common in the first two. We remain with 2y minus 3, then plus 1. 2y minus 3 equals to 0. So we can say from the brackets 2y minus 3, outside the brackets 2y plus 1 equals to 0. So from the first factor here, 2y equals to 3. So y equals to 3 over 2, which is 1.5, or the value of y equals to, we take negative 1 to the left, then we divide through by 2. It becomes negative half. It becomes negative half. Now I'm still having my calculator. Yeah, thank you you guys for being around. Thank you, Sylvester Mogeni, mathematics and physics teacher. I really appreciate your work. Thank you, Peter, from Bishop Mozaldi Senior School, Rongai. Thank you so much. Yeah, I can read comments from the studio, and I really appreciate your work. I really appreciate your work. So now we proceed to number 3. We proceed to number 3 without using a calculator. Just look at the question. Without using a calculator or mathematical tables, evaluate, leaving your answer in the form a root b plus c, where a, b, and c are integers. Just read that again. Not constants this time around. They are integers. So now we can talk about, let me sketch the information first. Let me put it on a diagram. So if we had a certain equilateral triangle of side 2 units, the hypotenuse will remain 2 units after bisecting it. Then we'll be having one here. And if it's right angle at this point, then we'll be having the root of 3. Remember, this is 30, this is 60. So when we talk about the tan of 60, then I expect tan 60 is supposed to be opposite out of adjacent length. Therefore, the root of 3 out of 1 just remains the root of 3. The other thing that we are finding in this case is the cosine of 30. So the cos for 30, the cosine of 30, cosine, look at where 30 is. So the cosine of 30 is supposed to be adjacent out of hypotenuse. So the adjacent length is the root of 3. The hypotenuse is a 2. So now we can now reframe the question and start with the root of 3 out of 1 minus the cosine of 30. Okay, so we write it now, the cosine of 30, sorry, as the root of 3 out of 2. So now if we are to simplify this now, then we'll be talking about the conjugate of the denominator. The denominator is already this one. So its conjugate shall be 1 plus the root of 3 out of 2. And it should also multiply the upper part. So we'll be having 1 plus the root of 3 out of 2. So this is going to be, when we open brackets on the numerator, the root of 3 plus the root of 3 times root 3 over 2. That becomes the root of 9 over 2. So the root of 9 is equivalent to 3 out of 2. This one now shall be divided by, at the denominator, we're supposed to do what we call rationalization. To rationalize, we need to square the whole part. The first part, so 1 squared, then the second part is also supposed to be squared, which is this other second part, the root of 3 out of 2. So when we square that, we're going to get root 9, which is 3 out of 4. So I'm having 1 minus 3 quarters. 1 minus 3 quarters that way. With this information, we can proceed to submit the answer. So this is going to be the root of 3 plus 3 over 2, then everything over a quarter. Yeah, everything over a quarter. So when we multiply by 4 all through, we shall be having 4, the root of 3 plus 3 over 2 multiplied by 4, that becomes 3 over 2 by 4, that becomes 6. So now the answer is here. And at this point, what we can see is that A, B, and C are all integers. They are all integers. All integers. Thank you. Thank you, David, from Thika Road High School. I'm reminding people, all the scholars, that we have a very serious program here whereby we'll be taking you through mathematics. You just have to register. You reach out through my number there, and you get to know a lot of details about the same. It is my hope that the program is going to bring some impact to you people. So please enroll, find time, and join us. Already the program started. Students have joined. So please, you can also join us. Yeah, you can also join us. But now we are at number 4. Number 4, the question says that a quantity R, a quantity Y varies partly as x and partly as the square of x. When x equals to 20, y equals to 45, and when x is 24, y equals to 60. Find y when x equals to 4. So we first find the relation connecting the quantities mentioned here. A quantity y varies partly. So y varies partly as x and partly as the square of x. So y, we can now introduce equal signs. Y equals to, once the equal sign is introduced, we have now to also introduce a cosine. So we can say this is equal to k plus another constant c. K should be multiplied by x and c by x squared. So with this interpretation now, we can get to the statement again and see that x equals to 20 when y is 45. So equation 1, y 45 equals to k when x is 20. So 20k plus, it's also going to reflect here. Look at this. Another condition is here for the same quantities. For the same quantities. So this is going to be simultaneous because, okay, I've not squared this one yet. This is 400c. So we now come up with the second possible equation, that 60, because it is the value of y, equals to 24k, then plus, we'll be talking about now x squared times c. When we square 24, ladies and gentlemen, I'm going to have 576. Now we multiply by c. Multiply by c like that. So now we can solve these two equations. We can solve them simultaneously so that we get the values of these particular constants. Therefore, to solve this simultaneously, we can use several methods, but allow me introduce what we call the substitution method, whereby from equation 2, 24k is equal to 60 minus 576c. So we'll be talking about k equals to 60 divided by 24. This gives me 2.5. Then minus, okay, we are having, we are dividing through by 24. So 576 over 24, it's still 24. So the value of k shall be, when we take 24 and we subtract 2.5, we are getting negative 21.5. So the value of k is 21.5. With the value of k, we can proceed to find the value of c. We proceed to find the value of c. I think there's something I'm almost mixing here, and that is remember they are known c. Yeah, c is still unknown. Now that this is from equation 2, look at this. This is from equation 2. That means we can now find equation 1, but with k re-expressed. 45 equals to 20. Sorry. Let me bring it together once again. Stay locked. Stay tuned. 2 into, instead of k, we are rewriting this equation. Instead of k, the value that we are supposed to write there instead of k, expression that we are having now. So this shall be 45 equals to 5 minus 48c. We can now find c. We can find c by saying 48c equals to 40. But now the 40 is negative. So the value of c will be 40 over 48 with a negative. And this is 5 over 6. Yeah, negative 5 out of 6. Negative 5 over 6. I hope you are still around and following seriously. It's just my hope that you guys are around and following so seriously. Now that we have one constant already known, now that one constant is known, we can find the other. We can find the other. So let's talk about now the value of k. K will be given by 2.5 minus 24. The value of c, -5/6. So now with this, we'll be talking about -24 into 5, okay, -5/6 to give us 20. Then we add 2.5 and we get into 2.5. So k equals to 22.5. At this point, we can now find y when x is 4. So y equals to, instead of k, 22.5, x 4 plus, instead of c, we write -5/6 into 4 is now being squared according to the general equation at this point. So 22.5 by 4 gives us 90. 90 minus -5/6. This one should be multiplied by 4 squared is 16, right? So we'll be having now -13 and a third. You see? So 90, then to this value becomes 76 and 2/3. 76 and 2/3. Number 5 is a log question, a log one, and we can solve it. The logarithm of 2 to base x plus, instead of the constant, can have 3, the log of 2 to base 2 equals to the log 2 base 2 of x power 4. You see? So now we can apply the law that says n, the log of a, equals to the log of a power n. So log 2 base 2 of x plus the log 2 base 2 of 2 power 3, which is 8, equals to the log x power 4, that way. So now we can have, we know that the logarithm of a number plus the log of another number, as long as the base is the same, we'll be having the log a multiplied by b. So the log 2 base 2 of x by 8 then equals to the log 2 base 2 x power 4. So now we can group some terms together now that we are done with the application of the logarithms. So we can say 8x is equivalent to x power 4. X power 4. So we can have division by x through, so that on this side x becomes power 3. Then if x power 3 equals to 8, then it means the x itself is the cube root of 8. So we can still find the x just like that. X can still be found like that. Make x the subject of the formula. To make x the subject in this particular formula, we need to talk about y plus x squared equals to, we open brackets, x multiplies whatever in the second bracket, then t also multiplies whatever is in the second bracket. At this point now, we'll be having y plus x squared equals to x squared plus xy plus tx plus tx, then we add ty, tx plus ty. Looking at this, you shall discover that x squared is appearing here, x squared also here. So that one cancels. After that has cancelled, then remember we are making x. So the terms with x can be left here, xy and tx. Then we are already having y on the left. Now we'll subtract ty at that particular point. The value of x, then we are having we are minusing tx. Sorry. We're minusing tx. Just a minute. Let me show you how the grouping is happening. We have y, it's already there. And then we had just said that the parts with x, which is xy and tx, to remain on the right-hand side. Then ty should also go to this side. Yeah. So y plus t then here y minus t y. How do you remain with x? Here we divide through by its coefficient. When we divide through by its coefficient, then we'll be having y plus ty. Then this is out of y plus t. Yeah, y plus t, like that. So we've made x the subject in the given formula. We can check this question, which is on a ratio theorem, proportional division of a line, negative scale. When the proportions are negative, how do we just proceed? The position vectors of points P and Q are just as given there. Then we are told that a point X divides PQ in the ratio of 5:3. Find the coordinates of X, hence the magnitude of OX. So at a point like this one, and I want you to listen well, you can still work with the ratios and you make them positive. Can I show you how? Okay. So we're going to just show you how. Let's say we are having points PQ, but now X is an external divider. So X is here, then we are having a Q, and we got our P here. So we have the coordinates of P as 5, 4, -6, as interpreted from this position vector. 5, 4, -6. Then on the other side, we are now having 2, -2, and 0k that way. Then X, Y, Z are unknown so far. X, Y, Z are unknown. So we will say this. We are given some ratios. That point X divides PQ in the ratio of 5:3. It means from P to where X is, we are having 5 divisions. Then from where X is back to Q, we are having -3. So we'll be having 2 and 3 will come here. That is how you interpret the ratios until they take a positive shape. Yeah, they are now positive. They are now positive. Then now we can apply the ratio theorem by saying, when we take the ratio 2 out of the total proportions 5 and we multiply by X, Y, Z, that way, we are supposed to get, okay, and we add, sorry, then we add, we take 3 out of 5, then this should be multiplied by 5, 4, -6. We are supposed to get 2, -2, 0. That is called the ratio theorem. Yeah, the ratio theorem. So now we have 2 out of 5x plus 3 over 5 by 5, which is just 3, equals to -2. You see now, 2 out of 5x equals to -5. How will you remain with x? You multiply by 5/2. 5/2, and this will give us -2. So the value of x is a -2. We go to x. Okay, that was x. So we now proceed to y. 2 out of 5, the value of y, plus 3/5 multiplied by 4. That becomes 12/5, then equals to -2. That is according to the y components now, according to the y components. So 2 out of 5y equals to -2 minus 12/5. Then now we're supposed to get negative 4 and 2/5. So how can we remain with y? By multiplying by 5/2 both sides. And this gives us a negative 11. With a negative 11 at that point, we can now consider the z axis. When we consider the z axis, then we shall be having 2 out of 5 z, 2 out of 5 z, 2 out of 5 z. Then we add 3 out of 5 by negative 6. That becomes negative 18/5. And this is equal to 0. So 2 out of 5 z equals to positive 18/5. So we can get the value of z very quickly. We multiply by 5/2, by 5/2, and this becomes 9. So now we'll be talking about position of OX being negative 2 according to xi, positive 9k. So now with these coordinates, we can talk about magnitude. The magnitude of x. This will be negative 2, we square. Negative 11 square. And 9, we also square. Then we take now the square root. Remember, we are finding the magnitude. So this shall be 4 plus 121 plus 81, and we take square root. So we are finding this to what accuracy? No decimal places provided. So we can talk about 14.35. Thank you so much for turning. We shall be continuing with the paper from that point.